Joe Cathell is a senior cybersecurity engineer at the TechGuard Security, or for TechGuard Security, excuse me. When not putting corporate security through its paces, he can usually be found at the Arc Reactor hackerspace.
Arch Reactor.
Arch Reactor hackerspace in St. Louis, Missouri. Joe is one of the founding members of Arch Reactor. He is also the co-organizer of the monthly STL 2600 DC 314 meetup, as well as a regular presenter. So please give your hands, give Joe applause. Thank you. Pardon the speaker.
All right. Thanks for coming, everybody. So who's ready to see some cat pictures? Yeah. All right. So, I mean, who am I? Well, Ben just did an excellent job of describing who I am. Well, there's a picture of me anyway. I don't remember how old I am from that. I found that recently and took a snapshot. Obviously, way young. Had more hair then. But yeah, I am a senior cybersecurity engineer for TechGuard Security. At TechGuard, I am one of the technical leads for the corporate pen testing team. I'm, of course, again, founding member of Arch Reactor, St. Louis Hackerspace, 2600, yada, yada, yada. This is actually my 4th time speaking at Freaknik, and despite that, you guys keep accepting me back, so glad to be here. I'd like to introduce Edison. Edison, of course, is a fur baby. He's about 8 years old now. He enjoys hiding in places humans can't get to and is not above trying to slip out the door when it's open, which is why a tracking system for him wasn't all that terrible of an idea. And for the record, his name is, he's named after the Intel Edison compute module, not the Thomas. There's a long story behind that, and if there's time, I'd be happy to tell it. So what is Whisker Watch? Well, if you didn't actually read the schedule, Whisker Watch is an effort to track Edison's location within my house via Bluetooth Low Energy. Why would I want to do this? Well, at the time I had recently bought a house. I mean, anybody here played with any home automation? A few of you. Okay. So good. We're going to dive into that quite a bit, so be a lot of new information for most of you. That's good. So why did I do this? Like I said, I had recently bought a house. It was 2020 when I did that, so right at the beginning of the pandemic. So I had to find ways to keep myself occupied. In other words, I arguably needed another project, even though my girlfriend would disagree with that statement. So I started dabble with home automation. And if you haven't started with home automation, it is a deep, dark, all-consuming hobby. Once you start, you just look for ways to bring in more and more things into it, regardless if it makes sense or not. Things like cats into your home, like you start home automating your cat. My personal philosophy when it comes to home automation is, if I'm going to have a smart home, it should actually be smart enough to know what I want when I want it. I don't want to ever have to flip another light switch. So when you're doing things like automatic lights, and if you don't want to switch a light switch on or off, like you're going to need some sort of presence detection. And in my case, it's going to involve motion sensors. That's what I'm using, just kind of your typical IR ping sensors. The only problem with that is I move around, and so does my cat move around. And so, but you know what? When my cat moves around, he can see in the dark. So, fuck him for light. Like, he can make his own light. So I needed a way to distinguish his movements from my own throughout the house. And that's where we got into this. So as the title said, here's the technology stack behind Whisker Watch. By the way, ChatGPT gave me the name Whisker Watch. Wasn't that brilliant? Like, I wish I could take credit for that. I'm kind of mad at how clever of a name that was, that it gave it to me. Anyway. As the title said, there's going to be Bluetooth Low Energy involved. That's going to be in the form primarily of a Bluetooth iBeacon tag that goes on Edison's collar. There's also several physical sensors throughout my house, one in every room for detecting the Bluetooth tag. There's Home Assistant, which in the role of this technology stack acts as kind of a data processor, providing desired output based on sensor data. In this case, reporting where Edison is and within the house. ESP Home, which is going to be the firmware and server backend for the sensors that are being used, plus some light Jinjitsu, which is a templating. Jinja is a templating language used in Home Assistant to format data. And we're going to cover all those in a little more detail. So first, you got to choose a Bluetooth tag. This is the one I chose. Primarily, the reasons are, I actually had a couple that I went through, and I found out something with iBeacon support is key. The reason is I needed something that periodically would send out a ping on a regular basis. Announce that, hey, I'm here. Some of the early ones I had, you had to like press the button to get it to report, and those weren't working. A friend of mine who had done some similar home automation stuff, also with cats, except he was tracking through Bluetooth, tracking how often his cat was using the litter box. But he told me that iBeacon was kind of the key Google search term you needed to use, because that does send out the pings. There are some other protocols like Eddystone. I don't know enough about them to know if they'll work in the system, but with the way I've got everything set up, if it's sending out a regular ping, it would probably work. I just happened to find the one I had, like I said, it cost me about $20 on eBay. And it has a nice little simple configuration app that you can use. It'll let you tweak things like how the frequency of the ping announcement and the transmission power, so you're not burning through your battery. With the default settings, I actually it's just like a little 25 CR battery coin cell, and I got a year out of it before I had to replace it, which I think that's pretty acceptable, and I'm happy with that performance. And that's with him like dragging it through his water bowl and everything and all that. So it held up pretty good. Yeah, as you can see, all these are pictures of Edison. That's when I got my server rack, and he climbed up on top of that because I was still installing stuff. So next up, you may be asking yourself at this point, well, what about AirTags? And you know what? That's a perfectly valid suggestion. AirTags are, if all you want is to get a ballpark location of your pet, that is a much simpler solution and much easier to do. But I started this project before AirTags were a thing. And frankly, it wouldn't have been as much fun if I just went and spent 40 bucks on an AirTag and called it a day. No, I wouldn't get to play with all the technologies I played with. So I haven't tested one, but I'm pretty sure because they kind of announce themselves regularly, they should work, I'd imagine. If anybody wants to give me an AirTag, I'll happily take it home and test it and let you know. So otherwise you can try it yourself, let me know. So moving on through the technology stack, we've got the tag sorted out. Next up is Home Assistant. Has anyone heard Home Assistant? 1, 2. Okay, not a lot. All right, this is going to be good. So like I said before, if you've ever decided you've got too much time and too much money, heavy on the time, by the way, home automation will take care of that for you. Of course, there are several pitfalls with the kind of current state of home automation. You've got how many different platforms? Everybody's heard of Philips Hue, Amazon Ring, Apple HomeKit, Google Nest, all of them. They all have their own proprietary protocols and security and privacy concerns. Home Assistant was this incredible application that open source home automation software that consolidates all of these platforms into a single application. So everything works with it. Like it's open source. There's all these integrations for everything. Thousands and thousands of supported applications and stuff that you can bring in and then have everything into a single pane of glass, so to speak. So you've got devices that are You can have one brand of smart switch or motion detector, inputting their results into Home Assistant, and then outputting and using that data to trigger automations that control other branded devices. So you can have, you know, Wi-Fi and Zigbee and all your different protocols and brands and stuff working together very nicely. So anybody that, if you're getting into, and if you're interested in home automation, start with Home Assistant. You'll see, you'll get there. You'd get there eventually if you're going to take it seriously. And so I'm not going to dive too much into setting up Home Assistant. I mean, it's not hard to do to spin up Home Assistant and pull in devices and start setting up automations, but there's also so much there that would be a talk in of itself, which I could have done, but I thought this was a little more interesting. Anyway, but so the basics are go to the website, download the image. You either spin it up in a VM, Raspberry Pi, or whatever hardware. They even have their own boxes. I think they're Raspberry Compute Module based that you can run them from as well. And that's nice because they've got some extra ratings, and stuff in there to deal with a lot of the devices that you find out there. You add your devices and start creating automations. There's another picture of Edison. He's watching Star Trek Voyager, so you can see I'm a good father, raising him right. So, we'll get more into Home Assistant as this progresses, but that's kind of the basic background. Like I said, it's kind of the data processor where it's taking the results from the sensors and processing and triggering automations based on that. So next step was to start building the Bluetooth LE sensors. This was actually the assembly line I had set up when I started doing that. I got a little row of them there. We're going to dive into it in details. I actually brought an example I'd be happy to show you later if you want to take a closer look at them, but we're going to cover it. These are a little more overkill for what you need. If all you need is like bare minimum, just you want to track Bluetooth LE and that's it, just have like Bluetooth LE scanners, all you need is an ESP32 microcontroller board. I think you've heard these a few times a day. They're brought up during the CircuitPython talk. We program them a little differently here, but yeah, that's the bare minimum you need for picking up the signal from the tag. My sensors actually started as like kind of environmental sensors, and so the Bluetooth tracking is something I actually added later. So this was kind of the initial inspiration when I saw this Hackaday article, where this guy, Soren Bai, a few years ago, figured out that there are these dumb air quality sensors from IKEA that were super cheap, and he could but the driver board had UART pinouts on some test pads on the circuit board. And if you soldered into it with a ESP microcontroller, you could pull the readings off of it, and now you've suddenly got a smart device for just a few extra bucks and some time soldering. These are the actual IKEA air sensors. I'm not going to try to pronounce that name. I'm not going to try to pronounce most things at IKEA. But it's a really nice little device for projects. Like it's got an air particle sensor in there. It brings air through it and counts like 2.5 parts per million is the resolution I think on it, and it's got a lot of room. And then on the front of it, there's just like 3 LEDs, red, yellow, green, to let you know the quality of air. They're like 15 bucks a piece. You can open them up. There's just 4 Phillips head screws, and there's plenty of space to work and add stuff on the inside. So this was basically the housing and kind of the first kind of sensor. So here's the overall shopping list for what you need. There's the IKEA sensor. They were about 15 bucks. They've gone up. They were initially like 12. Now they're 15. You need some ESP32s. I use the ESP32 Wemos D1 Mini because it fit. The footprint was very nice for this, and it's specifically if you've dealt with ESP microcontrollers, they're Arduino compatible microcontrollers that have built-in Wi-Fi. I'm using specifically 32s instead of the 8266s because the 32s also have Bluetooth, and being this is a project about Bluetooth, that's kind of a requirement. I also added temperature and humidity sensor because they were $1 a piece, and why not? The more sensors into Home Assistant, the more fun it is. Some cables, some USB-C power cables and power adapters you'll need as well because the IKEA sensors don't come with them. And I get those usually from 5 Lift. Like if you need, yeah, of course you can go to like Modern Price and get cables like by the pound dirt cheap. Those are great. But if you need like a cable really quick dirt cheap, Five Below's kind of like been my go-to, that $5 store. In addition to like USB power cables, they've got all sorts of like Bluetooth speakers and LED blinky stuff in junks. Like there's one down the road. We should all afterwards tonight like go shop and just like tear shit apart. I do that all the time. I just got scolded this week for buying a $15 metal detector. Well, I don't know how well it works, but $15, we'll find out. So the whole thing comes to about like under $35 you can build one of these sensors, plus some time. And like I'm not the first to do this setup. A lot of people have done this setup, particularly in the Home Assistant community. They've become very popular enough that IKEA themselves actually wanted to get in on the game. So they actually came out with an updated sensor. They still have the old ones. But they came out with a newer sensor. Again, I'm not going to try to pronounce the name of that, but it's got an actual LCD display instead of just the LEDs. They've got the same particle sensor, detecting parts per million, and as well as a temperature and relative humidity sensor. The cost, they've also, was it a total volatile organic compound sensor? I don't know exactly what that is, but maybe I'll see if eBay has one I can add to my existing sensors. But they cost about $50 a piece, and which is a little more than the $35 we've just parted out for the ones I'm dealing with. They do run off of what's called Zigbee instead of Wi-Fi, which is another wireless protocol, much lower bandwidth, used a lot in home automation. Like Philips Hue runs off Zigbee. A lot of smart bulbs do, and that's great because you're not taking up your Wi-Fi spectrum with these little devices, but also they currently require a smart home hub from IKEA to integrate with them. And like when they were announced, IKEA was promoting that these will adhere to the Matter standard. And if you don't know what Matter, with all the, like I said before, there's this huge mishmash of smart home technologies right now, and yeah, we're all smart enough to go get Home Assistant and learn to integrate it ourselves, but like, the non-techies out there, they just want all their stuff to work together. They just want to be able to say, hey, so-and-so, like, turn on my lights and have it work no matter what. So that's where there was an industry open standard that has been developed to facilitate communication between various brands of devices. And a lot of companies are starting to adopt it. And everybody's kind of like really excited about it in the home automation community. But even though IKEA has promised that these are supposed to work with that, they haven't actually come out and pushed that update yet. So I don't know that these would actually work. So save your money and like build your own. Plus, we get the experience. The next step is so here's the overall the sensor. This is the inside of what my sensors look like. You can see the main LED driver board there, and then some cables running into it, which lead to the IC and the temperature sensor. There's the contacts that you need to solder to get to the UART output. The two rightmost contacts on those test points are labeled for ground and voltage. You'll solder those to the ESP, which will provide power from the board to the ESP, so you don't have to have separate power to the ESP board. It'll all come out of that single USB cable already powering the IKEA sensor. That second to the left contact is the actual UART transmission line. That's what you'll solder to and run to the ESP board. The temperature sensor is pretty much the same thing. 3 wires, ground, positive, and data. I found the best place to put that temperature sensor is like right on the top of the board. It gets it out of there's plenty of room up there, gets it out of the way of the particle sensor, because you actually want airflow going through there, because there's a little fan in there bringing air in. Needs to count that. If you're obstructing that, your counts are going to be off, and it's not going to work right. Plus, having it up there with the air blowing bastard for the air quality sensor, you're getting a nice sample for the temperature and humidity as it's going by it. And touch a hot glue at the top. Works very nicely. Holds it up there just fine. Here's the pinout for the ESP32. As you can see, there's ground voltage and GPIO 17 we've got running to the air sensor, and for the temperature sensor we're using GPIO 16 as well as ground, and the temperature sensor runs off of 3 volts, so we're powering it off that 3 volt line. So just really 6 solder points on either end. That's all it takes. Excuse me. Oh, that was loud. So once you've got a bunch of these built assembly line style, you're going to want to test them, put them all back together, make sure they work. I recommend when you first set these up, like have them all kind of clustered together in the same location. That gives you, that way you can, when you get them all set up, you can view the sensor data and like, okay, these are all in the same location. They should all be the same temperature and humidity and everything, but if they're wildly out of whack, then you know you've got to like tweak the calibration or whatever, or make adjustments in the sensor data. But so other than that, just kind of general smoke test, make sure they're working. And when I did my initial test, I found out about 10 minutes later, I had left them alone, and the cables I used, he ate all but 2 of them, so I had to go buy all new cables. It didn't take them long at all.
Privacy focused.
I mean, they were just power cables. There was no data going across them, but yeah. Oh yeah, I guess he didn't, tracking him, I guess. I haven't even got that set up yet. I don't think I even have the collar on them yet. Anyway, so yes, go get new cables, ones that are less tasty, or get some of that like bittering that you can put on your cables so pets don't eat them. I think you can use it with children too. If you have children eating cables. I don't know. I don't have children, so maybe I don't know what they do. So we've got our sensors set up, and now we've got to integrate them in the Home Assistant. We're going to use ESP Home for that. ESP Home is both kind of like the back-end server and the firmware that's going to be running on it. What ESP Home is a system that allows for easy programming of wireless capable microcontrollers like the ESP8266 and ESP32. It's maintained by Nebukasa, the developers of Home Assistant, so therefore works really well integrating into Home Assistant. And there are hundreds of like various components that are supported. You can either building your own kind of IoT device, kind of like we are, just getting the individual sensors and bringing them into the controller, or if there's a lot of like off-the-shelf, like from overseas, cheap smart devices that run mostly on these chips that you can actually reflash with the ESP Home firmware, and you don't have to use the really sketchy, suspicious app anymore, and just have it integrated into your Home Assistant set up directly, which is really, really nice. Home Assistant, the supported platforms, like I said, it supports ESP8266 and ESP32. Those were the original chips, hence the name ESP Home. With the increase in popularity as well as supply chain issues, Raspberry Pico became really dominant in this area, so support was rolled out for that, as well as they've recently, within like the past couple months, added support for BK7200s and RTL 9700 chips, which if you haven't heard of, I didn't heard of them until I bought one of these devices. I actually bought a lot of these devices. There's a brand I knew I could traditionally reflash, and I bought like 12 LED strips that I was going to reflash them all and do all sorts of pretty colored stuff. And I got them open. I was like, these aren't the same chips, because the company had figured out that we're just buying their cheap junk and putting our own firmware on it and not using their spyware. But since ESP Home has added support for their new chips, so now I can go back and reflash these. That's going to be like one of my next projects. Setting up ESP Home is really simple. It's as simple as going into the add-on store within Home Assistant and clicking install. That's all there is to it. Once you've done that, you'll browse to the ESP Home tab within Home Assistant. You'll click New Device, and it'll prompt you for what are you going to call the device. So you got to name every device, of course. If you're going to have a slew of these sensors, some consistent naming patterns is probably a good idea. For instance, mine all have the name of the room that the sensor is in to identify what it is. Mine all say like air sensor bedroom, air sensor kitchen. So just be consistent. It'll help yourself later. Once you've done that, then it'll ask to connect the device by USB. You've actually got to connect directly to the ESP32 chip, not the USB power on the IKEA sensor, because there's no data there. And then when you hit connect, there's other ways you can download the firmware and flash it alternatively, but this really is the easiest way. Despite how uncomfortable I am that my web browser will ask for hardware access to flash hardware connected over USB. I don't really like it, but you only have to do it the one time. It is on your local network, so it's not like you're letting some random website do it, access to your home network. It is all kept locally, and you do it once, and then from then on out, you can flash over the air over Wi-Fi, and you never have to deal with it again, unless you're adding another new device. So once that's done, you'll get that sensor will be added to ESP Home. If you look at the basic config, there'll be a YAML file, and we're going to go over some of the basic breakdown. It'll start with the kind of the settings you specified when you initially added it. The type of board, what the name of it is. Then there'll be some like API keys for talking to Home Assistant and ESP Home. Then we'll get kind of into the meat of it, where you've got to specify what your wireless config, which of course is SSID, wireless key, all of that. There's also a failback Wi-Fi access point that if for whatever reason your Wi-Fi goes offline or you type the password wrong, it'll fail over to the hotspot, give you a captive portal when you connect to it, so you can actually adjust some of those settings directly on the chip itself, and then get yourself back up and running without having to plug it back into the USB. And then, like the real meat of it, below that will be, you'll start defining the sensors. First kind of block will be kind of like communication, that we're specifying that we're talking to the particle sensor, over GPIO 17 using UART. That we're also going to be doing some Bluetooth LE talking with the Bluetooth tracker component. Yeah, as you see, there's actually a component, ESP32 BLE tracker. And what that does is it basically takes it scans for a specified device and reports stats on it, like signal strength. And of course, we'll want to specify the other sensors. Like I said, we're going to name what our sensors are going to be called within Home Assistant, such as the air quality sensor. You see, we're specifying. You determine what Bluetooth tag you're tracking by the MAC address. Simple enough. And then, again, telling it that we've got another temperature sensor on GPIO 16, and then what it's going to be called. So once you've got YAML file configured, you go ahead and hit upload, and it'll flash it again. And then you can go ahead and open up the log, and you'll start seeing all this data stream in. So you'll know that your device is now connected and reporting. Once you've got that, we can go ahead and look at the device view under Home Assistant. We'll see the sensor device, as well as what sensors it has reporting in, so we know that's being logged. And we've successfully built some environmental Bluetooth LE sensing tracker. Now I can see you're all kind of glazing over at this point, because what you came here for was to figure out how to track kittens around your house, right? Oh, sorry, we had to get through some of like the background on how to set this up, and now we'll get into that. So once we've got these sensors built, how do I actually track Edison around my house? Well, it's really quite simple. You know, I created a card on the dashboard in Home Assistant with like all the sensor readings from for the signal strength from that was picked, the signal strength of the ping being picked up from the tag on his collar. So and if you can pretty much look at it, the highest value, which these are negatives because we're dealing with decibels and math and physics and stuff that's kind of beyond me of why we do that. But the highest value is negative 67. That's because that's the sensor he's closest to at this point when I took this screenshot. So I know he's in the living room just by looking at that, which, okay, we've tracked him, mission accomplished. But we can do a little bit better than that. Like, you want to look at that and see those numbers every time and check, like, who wants to sit and think? You just want this to happen, right? The house is supposed to be smart. It's supposed to be doing the thinking, not you, right? So that's where we get into Home Assistant templating. Templates are an advanced feature that lets you control how data is formatted and presented to entities within Home Assistant. It's driven by a Jinja 2 engine, which itself is based on Python. Now, just because it's Python, that should not be an implication that Jinja is easy to use. I didn't find it easy to use. I actually had to get some help with it, but it works. So to set up a template sensor, we go into our device settings, and there'll be a spot called helpers where we can basically create helpers. They're kind of like variables within Home Assistant in a way, or kind of like objects that aren't already paired to an existing device, physical device. They're kind of virtual devices almost. So you create a new you create a template sensor, and once that's set up, it'll function like another sensor or device within Home Assistant. You've got to invite, and once you've done that, it'll prompt you for some template Jinja code. This is the code what we're using. And basically what I've got going on here is it adds each reported signal strength from each sensor into a dictionary. And any sensor, and sometimes sensors fall off because Wi-Fi, it's at the edge of the house, it didn't report the Wi-Fi, or it didn't pick up the Bluetooth tag because Edison's on the far side of the house, so there's nothing to report. So every now and then I get like unknown values in my signal strength. Well, I can't sort on null. So anything, if there's not an existing value, it just assigns it to -999. That way it's guaranteed to be at the bottom. And then I just sort the dictionary by the highest value and report the key, which is the key name is, which I've just specified as whatever room I'm in, or the sensor is in. And so all that gobbledygook is put into the sensor. We've got now another object, and if I go back to that same template sensor card, I can go ahead and add my custom sensor, where is Edison, and you can see, according to the signal strength, the highest signal strength there on the list is the living room cat sensor, and the where is Edison sensor is actually reporting that he's in the living room. And voila, we've got a kitty sensor. So now we have a kitty sensor, but that's great. Now you can look at it, and there's a word there that tells you where he's at. But I think we can get a little fancier with it. So decided to go. I wanted something a little more fun. The next thing, something a little more visually interesting is, anyway. And so what I did was I kind of created a floor plan. This is not my real floor plan, by the way. I mocked up one for you guys. But mocked up a very rough floor plan of the house. If you've got proper architectural drawings of your house, by all means, you can actually import them in. But I did rough diagram will work because we're not dealing with like super fine accuracy here. And then there's another item you can put on the dashboard of Home Assistant called a picture elements card. And what that is, you specify like some sort of image, and through the logic within Home Assistant, you can specify where putting icons overlaid on top of the image. So this, so now we can use the sensor data, the new sensor that we've created from the template, to actually place a little cat icon. You can see over. Place a little cat icon over the floor plan and see exactly what room it is just at a glance, instead of having to read. So this is the logic being used. It is kind of long, but the long and short of it is like it's just YAML, and it's a series of if true statements, conditionals that basically, if the sensor says he's in the bedroom, put the icon in the bedroom. If it says he's in the living room, put the icon in the living room. And you just specify where by like giving basically XY coordinates on the image. So we've got a cat tracking sensor now, and it looks really pretty because you can just like look at a single pane of glass and know exactly where your pets are. Now we've gone through all this like overkill just to like figure out where a cat is. What else could we do with this? Well, it's not simply limited to cats. Any other pet that wears a collar should work just fine. Probably wouldn't work with a goldfish. Don't recommend that. But yeah, cats, dogs, bunny rabbits, whatever. House guest presence detection. I mean, in addition to like, I'm going to have to add some sort of presence detection for myself so that the house knows whether it's me or the cat making the movement. And you can either give a guest a badge to wear while they're over at your party, which seems a little rude, but you can probably also do it off the cell phone. You know, if they have their Bluetooth on their phone, your phone's still pinging out Bluetooth, so you can probably track that as well. But if you did want to hand out badges, you could definitely pretend to be Bill Gates. I don't know, the older, probably above 40 people in here probably remember a few years ago when Bill Gates, probably like what, 10, 20 years ago, when he built this big house and it was all in the news, and they were calling it like Xanadu 2.0 or something like that. And but the big deal was like all his house guests would get badges when they arrived at his house, and as they moved from room to room, there was digital art on the walls that would change to their preferred art as they moved throughout the house to accommodate the guests. Well, now we can do that with off-the-shelf parts for like just a few $100s. So suck it, Bill. What else we could do with it? We could also detect unexpected Bluetooth signals. I don't know how many of you followed DEF CON this year. Alan Meekins presented a talk on detecting law enforcement by Bluetooth, like at the door, with similar concepts. Basically, like all these like body cameras and even some of the tasers and such that they use now have a lot of smart technology built into them. And your local PD very frequently just leaves everything at the default settings. And so they're broadcasting Bluetooth pings looking for pairings as they just walk about their day. So you can set one up by the door and you detect any suspicious Bluetooth at the door. You can, and it's got a MAC address, so you can, based off that, identify at least the brand or the vendor. And hey, if the vendor for a body camera or a taser company starts showing up at your front door, maybe activate the locks, I don't know, your smart locks. Have it turn out all the lights. So that, I mean, that's a very real thing you could do, or anything else. Like I did at the very least like to set up just like any kind of strange Bluetooth at my front door I kind of want to know about. Like I got a lot of like door-to-door salespeople through my neighborhood. It really gets kind of annoying. So I wouldn't mind just knowing when they're there, just so I can ignore them. So what's next with this? Next am I going to do with this project? My first thought was like, I was really hoping to try, I worked on this a bit, was trying to get some more increased accuracy. That by the way, that's when I first brought him home. There was another one of him, like he was like this big on my shoulder. That was the first time I held him. But that's when I first brought him home. He's much bigger now. But increased accuracy. I was actually getting like what I thought was triangulation, but it turns out I was looking for trilateration, which is, using signal strengths to kind of like to a more or less exact positioning. I consulted a lot of GitHub Copilot to help me try to write some code for it. It did warn me, is like, hey, maybe this isn't something you want to do with like Jinja templates. Actually, it says like, this isn't like the best format for like language for doing this kind of thing. You may want to consider something else. I said, do it anyway. And it did, and like I'm sure, like from what I've been able to research, the math was right. But the end result was still like the location of Edison was either thousands or trillions of meters off. And basically, from what I've been able to gather, like it was literally at an astronomical value that I was dealing with. I'm like, that's not. My house was like 15 meters long, like tops. Like anything bigger than that, I was like, that's way off. But basically, from what I've been able to gather, is old house with mystery wall contents does unpredictable things to Wi-Fi. That, and I'm pretty sure like just the physical area of my house is too small. Like you want to do like trilateralization of like signals to locate people. Like works with cell towers because they're far away and it's wide open space for the most part. Small spaces, it is a lot harder, particularly like it all depends on like the frequency you're using. You got to know the frequency. You've got to know the like transmission power. You got to know all sorts of stuff. Like you even have to know like you do have to know what's in the walls, whether it's plaster, concrete, glass, metal. Like that all apparently changes the equation a great deal. Boy, I'm falling in love with GitHub Copilot. I hate to say it because like it did a really good job at like providing me some like values for some of these things. Like this is maybe what you need, but again, this isn't the right script for the project. But so I don't think it'll work in a house. Maybe a warehouse, but like you just need more space to do it properly, from what I understand. I may like decide I hate myself and try to dive back into it at some point. But, I think more immediate is another project is I got one of these treat dispensers, like the Skype for pets, where like you've got the app and the camera and you can talk to them and dispense treats remotely. Of course, like I'm always suspicious of those, but I got one on clearance, and it had like the treat dispenser, the voice back and forth, and a camera, and a little laser pointer you could tease them with. But it was like a no-name brand treat dispenser with an equally no-name, suspicious-looking app that I did not want to put on my phone. So, and I did even look at it, like there was no thought in security, because I looked at it, broadcasted an SID, I'd connected to it, they left Telnet wide open with root. I'm like, I am not putting this on my network. So my next plan is to take it, I'm gonna gut out the inserts. It's got some nice 9mm servos in there, but I'm just gonna put in like an ESP32 camera module, which is an ESP32 with a camera. that you can run as a web server and get a stream off of. They're a lot of fun and pretty inexpensive. And I'll just wire the servos into that along with the camera, and then just probably flash it with ESP Home, and then I've got like a custom built little treat dispenser for Edison, and my goal is to I'll add the Bluetooth sensor, so maybe like if he gets close enough to it, and it's with, I don't want it to be every time he walks up to it, it's just treat after treat, but like, once an hour if he gets close enough to dispense a treat, or maybe just start randomly turning on the laser and moving it around. I think that'd be a pretty fun project, and I think it'd be pretty simple to do. So that'll probably be the next integration into this that I do. So yeah, that's what I got. Any questions? This is Arduino, by the way. Arduino, he was alive when I started this project, but he unfortunately passed away last year at like 14. So I miss him. Anyway, any questions?
How old is Edison?
Edison's about 8. Yes.
How far can a Bluetooth transmitter range?
The one I've got, so the transmitter's is the tag, and by default, according to the app. So I don't know enough to say that it's accurate, but according to the app, the default power level is set at like 25 meters, which is far exceeds my house. You can increase it to, I think, up to 50, but then that's drain the battery. You can also lower it to like within the teens. So it's variable according to the particular tag I'm using. And the range is actually going to vary completely depending on what tag you buy. I don't know how far it is, what the range is of an air tag versus the one I bought or any of the others, other brands that are out there. Yeah.
Is Bluetooth like tag the only tag to use, like, trying to track something, you can use something else?
I mean, anything that, in theory, anything that transmits a radio, you could track similarly. This is specifically designed for Bluetooth because it's Bluetooth. I'm specifically detecting Bluetooth signal strength on a Bluetooth radio on a Bluetooth-enabled microcontroller. But if you have the right radios and you put in the effort, yeah, you could certainly do something else. I mean, if you're thinking of like NFC or something like that, you could certainly go buy like an NFC or RFID sensor, wire it into ESP Home, read it. I know there are RFID sensors that will work with ESP Home. In fact, we use them for access control at the hackerspace in St. Louis. Our access control system is ESP Home based and tied to our membership system. I should get Bob to do a whole other talk on that. Actually, I'll hound him about that for you.
All right.
So, but our RFID and NFC is usually much shorter range depending on what kind you're using, and then so you'd need a lot more sensors for that. Any other questions? Yes.
Did you ever go, you might have gone over and I missed it, but did you go over a way where it detected either you or the cat if you walked into a room? And
I haven't gotten to the point where it's detecting me yet. The primary, the whole motion sensor turning lights on and off for me kind of took a backseat once I got into tracking the cat became the priority, regardless. So yeah, I should have put that on the what's next slide. Actually finish the project.
I was wondering, we were going to circle back to that.
No, I didn't get to that. But I mentioned, basically I'd either have I had a smartwatch for a while. It just died. I got to get a new one. You could probably do a smartwatch or Bluetooth on your phone. Something you're already carrying around. I mean, you don't want to have to carry a tag around your own house, but because there does become the issue where Edison follows me around the house when I'm home. So if we're both walking to the same place. Any other questions?
Which room is engineering?
My lab.
No.
Yeah, computer lab. Got that. I'm a Trek nerd, surprise. Yeah, and the library, that's the comic book room. So yeah, I live alone, so I can call them whatever I want. Do we have time that I can tell the story behind Edison's name?
Sure.
Okay. So it actually starts with Arduino. Back when Arch Reactor started, holy crap, 14 years ago? Yeah. So we were about a year in, not even a year in, we were at a stray cat wandered in to the building and started hanging out with us. He was very friendly and everything, and he hung out with us, and at the time, one of our members was his dad was a vet. So like, he was very adamant, no, we can't just let this defenseless animal wander back out in the street. So we built him a crate, he took him to his dad's office and checked him out and everything, and a couple days later, posted on our message boards like, cat's fine, but does anybody want to take him? Because if not, we've got to take him to Humane Society, and if nobody takes him, that's kind of a death sentence. And I was in between jobs at the time, but I had been thinking about getting a cat, and I was like, I might get one, but I'm in between jobs, so I can't afford like the shots and the food and everything right now. And but that was the cat. Arduino was the cat, and that's where he got the name. It's like he wandered in the hackerspace, and we called it, like somebody said, we should call him Arduino because we were all playing with Arduinos, and we thought that was brilliant. And it kind of works because like, in addition to like it being in a hackerspace, if you look into Arduino, the name is like Italian for like little buddy or good friend. And I was like, oh, that's kind of adorable for a cat. And so yeah, I ended up, everybody donated a bunch of food and litter for me, and the dad vet, because he was going to a good home, comped all the like medical needs, all the shots and everything. So I adopted Arduino, and I had him for several years. And then a few years later, we had another member die Diane. She didn't die. She fosters strays that have been rescued, and so every now and then she'd bring in like a litter of cats into like the business meetings and stuff because they were freshly born and they needed to be desensitized to being around people so that they could be adopted out. So there were several meetings where we were just all like holding cats, talking about the same space. There should have been one like with the little kitty. I showed that was the first time I held it, so that was from one of those events. And I had made the mistake of telling Di one time that like, we're bringing in all these cats. Like, I was like, one of these days you're gonna bring in some little cute fuzzball that I'm gonna fall for and absolutely have to take home. And Joan needs another cat, and made it her mission to find another cat. So she kept pushing cats on me. And then, so Edison's name came from, she brought in a particular litter one night, and none of them had names yet. And it's like, well, what are we gonna name them? I'm like, well, according to Arch Reactor history, we traditionally name cats after microcontrollers. We had Arduino, that was the only example we had thus far. So we went to Adafruit, just looked at their microcontroller list, and we named the litters like Parallax, Gemma, Feather, Edison, and they all got adopted out except Edison, and I eventually ended up with Edison. So yes, Edison, through Arch Reactor history, is named after the Intel Edison microcontroller board, not the other guy. Thank you very much.